maybe, I mean, I will pose the question to one of the panelists, each of the question. Then, of course, you can, I mean, of course, I mean, if you want to add anything to any questions, please feel free to do. So we still have about like a couple of minutes to go. All right. Maybe like people are still joining in, but we are already a couple of minutes past time. So let's start with the proceedings, and in the meantime, people can continue to join. And first and foremost, thank you to the esteemed panel for taking your time out and joining on a Saturday. Thanks for that. And to all the participants also, I mean, great to see you all. Thank you all for joining in, taking your time out. So I hope to have a great session. It's a very important and a very interesting topic that we have for all of you today. And as a part of our webinar series, today we have a panel discussion, in fact, where we would be discussing about the generative AI in financial analytics, right? So to set the context of the panel discussion, before setting the context, I mean, as always, let me just quickly start by giving you a brief laydown on how we would go about the session. So first, of course, we will be discussing on all the various topics, and post that we would be having a Q&A session. So we would be taking up all the questions. So keep your questions coming. Make the sessions as interactive as possible. We are always happy to answer all your questions, doubts. So please keep the questions coming. I mean, you can pose your questions now. You can pose your questions during the session. I mean, if you need any further clarification on any of the discussion that we are having, or of course, again, you can add your questions after the session as well. Right. So yeah, and also for all of the participants, a very interesting thing that actually we would be doing is we would be also be conducting a quiz at the end of the session before the Q&A, and I mean, it has prize money as well. So essentially, the winners, particularly people who answer all questions correct, they would be, the top 5 people actually would be getting cash prize of 10,000 rupees. And if the top 5 is from people who have not answered all correct, then the second, third prize winners will get 5,000 each, right? Also, I mean, a very exciting thing is if any of you at the end of the discussion or later on, if you have won a prize and you want to join any of IIQF courses, you can select any course to join, and the winners will get a scholarship of up 80% waiver on the course fee. So you have a lot of prizes to win, maybe about 5 lakh worth of scholarship, cash prizes. So yes, with all of you, I'm also very excited to start the session. Let's start the session with a brief intro, and then I'll pose the questions, and of course before that I'll introduce the panelist as well. Right. So first of all, I mean, as you all know, generative AI or GenAI, as we call in the industry nowadays, is poised to offer innovative and transformative solutions for financial analytics and modeling. However, the futuristic adoption of GenAI in financial analytics depends upon the evaluation of a broader market and the regulatory framework to address all the concerns as well, the ethical, privacy, transparency, interpretability, etc., all the challenges and concerns. So, I mean, to discuss all these points, we bring all the IIQF experts, and we want to have their insights into the future of GenAI adaptation for financial applications. So let's deep dive into the panel discussion with our subject matter experts, right? So first, allow me to introduce the panel one by one. First, I'd like to welcome and introduce Sanjay Bhatia, Mr. Sanjay Bhatia. So Sanjay has done his MBA in finance and MSc in machine learning and AI from Liverpool John Moores University, and a postgraduate diploma in machine learning and artificial intelligence from IIIT Bangalore. He is currently working as a director with UBS Group in the risk modeling and analytics team, and is handling model risk management and control, particularly in the CRO function. Sanjay is a risk management and analytics professional with more than 15 years of mainstay experience in risk models and methodology space, encompassing Basel, advanced AIRB, IFRS 9, IMM, and SSER exposure, XVA, FRTB, OTC derivative pricing, and other advanced modeling topics. So Sanjay actually is who has been working at the in the forefront of amalgamation of the machine learning and the finance areas, right? So he has worked with various foreign banks, Barclays, RBS, Citi, Credit Suisse, particularly in the risk consulting domain. He is very passionate about imparting practical model understanding and insights, and has been a professional trainer for corporate and investment banks. And I personally can vouch for his great dedication to imparting knowledge. He has been one of our leading faculty for many years now. So his areas of interest are credit and counterparty credit risk, market risk, stress testing, stochastic modeling, quantitative finance, and machine learning. Next, the part of the panel, we also have Mr. Ritesh Chandra. Ritesh also is a greatly experienced banker with more than actually 15 years now of experience in credit and risk management, and he has worked as president of a leading private sector bank. Though I'm not updated here, but Ritesh is currently, is more, he has taken a sabbatical from the industry, and he is devoted full time to imparting knowledge in our field of finance, risk management, quant, machine learning, and all these areas, and banking, of course. So prior to his stint with as a president of one of the private banks, he was working as an IT consulting and had worked in a variety of roles in India, China, and Canada. He is very passionate about teaching, and he has been conducting workshops and training programs for the last 6 years. His areas of interest are credit risk, quantitative finance, statistical learning. Ritesh is a PGDM, which is the MBA from IIM Calcutta, and he has also done his BTech from IIT Kanpur. He has also done his CFA and is a member of Board of Studies for IMT CDL Ghaziabad, and currently is involved with multiple educational initiatives, right? So welcome once again, Ritesh. And the final panelist that I would like to introduce is Harshit. Harshit is dynamic. I'll mention dynamic because he is very young and he has done a lot of work already. So he's a very dynamic data scientist, currently serving as a senior associate data science at NPCI with extensive experience specializing in NLP, that is natural language processing, and generative AI technologies. He holds a master's in engineering from LD College of Engineering, and also has a bachelor's degree from Adani University, providing with a strong technical foundation with comprehensive hands-on experience and expertise in LLM fine-tuning, machine learning, OCR applications, and advanced NLP techniques. He has successfully implemented production-grade solutions across multiple industries, combining theoretical knowledge with practical experience to deliver impactful AI solutions and deliver technological innovation. All right, so yeah, that was like a little long introduction, but yes, I believe that always helps to know the panelist. Okay, so now like again, maybe we will start the discussion, and maybe we'll start the discussion. First question I would like to pose, and I'll start the discussion with Sanjay actually. So first and foremost, Sanjay, for our audience, can you set a little background on generative AI as a paradigm of AI, and particularly how it's differentiated in its capability, particularly from the broader AI that we have always known?
Okay. Thanks, Nitish. Thanks. Welcome all the panelists on board, and welcome all the participants and enthusiasts. To set the tone right, in just a brief background, that broadly AI is somewhere maybe not it's very pervasive, and it has filtrated all the different industry sectors as well as different application areas within an industry or sector, specifically
Right.
BFSI. uh, the generative AI, the genesis of generative AI is somewhere could be traced back to 2014 or 15, when Ian Godfellow, right, proposed one particular architecture, which is a neural network based architecture, which was basically having generative capability.
Right.
Now, that sets it apart as a specialized paradigm where, of AI, where, you are mostly concerned about generating new data, right? Be it
Correct.
images, with where it started, be it text, be it videos, be it maybe even the financial data, or be it any kind of signal data as well. So it has ability to generate different types of data. And how, what sets it apart from the generic AI is, in generic AI the focus is more on prediction task, where somebody would learn some kind of relationship, identify a few patterns, maybe understand the functional form based on the past data between maybe the data set you have, to do predictions into the future, to maybe a forecast for the future. But in generative AI, knowing that maybe specifically in BFSI there are multiple challenges with the data scarcity and the inadequacy of data, right? Generative AI has been a boon in maybe generating new data sets, somewhat synthetic data set, although obviously it would have its own challenges and concerns around how those could be appropriately used, whether there's a
Right.
data privacy or confidentiality concern. But if one to look at generative AI as a differentiated field, it would be basically cornerstone of it would be the generative ability, the ability to generate, ability to create, ability to produce new data set, learning from how the original data set look like, right? Knowing something about the original data set, it try to mimic that particular distribution of the original data set, and try to create new uh, data instances, sample points, examples, which would be over time be looking undifferentiated from the original data set. Yeah.
Yeah, absolutely. So, I mean, the same question. I mean, if any point, Ritesh or Harshit, you want to add anything to that?
I mean, so Nitish, I think can you hear me?
Yes, yes, absolutely.
So I think Sanjay explained it pretty comprehensively in one line, if I can summarize what he said. So uh, traditional AI is more about classification, regression, clustering problems. Essentially, the idea is to understand a pattern or to make a prediction, whereas Gen AI is about predicting the next token in the sequence. If it's a sequence of words, sequence of pixels, the idea is to create the next token. And if I can give an example of that, say there is a company like Goldman Sachs. So if they use traditional Monte Carlo simulations, then the model cannot sometimes predict unprecedented events like COVID-19 supply chain disruption. So here they can use a generative AI tool, say a GAN architecture, which can create these synthetic market shocks. That means oil price has crashed, FX volatility is there, and you will have a discriminator which will evaluate the plausibility of these scenarios with say last 50 or 60 years of historical crisis. And they would
Correct.
generate these 10,000 scenarios, including simultaneous equity and bond crashes. And with such kind of a simulation, ultimately the bank can improve their capital reserve accuracy during
Correct.
such unprecedented periods. So that is why it has become so popular, because you are able to generate certain things which people may not have witnessed in the past at all, and therefore traditional simulation systems may not help you in that context. So I think that is the bigger idea here.
Wonderful. That's greatly summarized. Harshit, anything you want to add on this?
like adding on the Ritesh point and Sanjay points, right? See,
Yes.
LLMs have got a unique capabilities, like
Right.
something called the zero-shot prompting. So, though we haven't simulated any scenarios while training any language model, but LLM has the capacity, like looking at the past data, it can simulate a narrative for the futures, right? Forward-looking summaries, or it can simulate and set the narratives for the future. And
Right.
the second thing, if we talk about from the asset management perspectives, right? So
Yes.
currently, people are using a generative AI, right, for extracting the sentiments, signaling the news. If in the current perspective, if we look at the Iran-Israel wars going on, right? So based on the sentiment analysis, extracting the news, they summarize it and set the narratives that how the oil prices are going to fluctuate in the futures, right? And how the
Right.
companies have to manage their expenses. So yeah,
Understood. Yeah.
that's a narrative I talk about.
Great. Okay. So that's a great start to the session with all the panelists sharing great thoughts on that particular question. Okay. So Ritesh, to you, the next question, I'd like to start with you. So knowing the transformative potential of generative AI, can you highlight the bottlenecks and roadblocks for Gen AI adoption in finance?
Yeah, I think a couple of them are there, Nitish. The first one that comes to my mind is regulatory compliance challenge, because the financial services industry, it essentially operates under some of the strictest regulatory frameworks. Now, the
Absolutely.
challenge with Gen AI is it's more black box in nature. So if a model generates a credit decision or a trading recommendation, then regulators will require a very clear explanation about the decision-making process. So current generative models, while they are quite powerful, they often cannot provide you the level of granularity that is auditable and which is now required, say under a Basel III or the MiFID II, which is the European Union directive.
Right.
So if you look at the European, just to give you an example, if you look at the European Union's AI Act, they classify AI systems used in financial services as high risk systems, which
Right.
means that you require the financial institution extensive documentation, risk assessment, and human oversight, which the current Gen AI systems may struggle to provide. So that is one big issue. The second big issue which comes to my mind is model hallucination. So
Right.
unlike
Okay.
other industries, where creative interpretation might be something that people are happy about, in finance you are looking more at rigor and precision. So if a generative AI model hallucinates and creates a plausible sounding, they sound very reasonable, but factually incorrect financial information, then the consequences might be severe. Say a model might generate a very realistic looking earnings report whose numbers are fabricated, or they can create a very
Yeah.
convincing but factually wrong regulatory compliance documentation. And I believe there was an instance like this in Goldman Sachs, where they were testing these generative AI models for research report creation. And occasionally, what would happen is that the model would generate fictitious financial ratios or even invent M&A, that means merger and acquisition activities that never occurred, and therefore they required extensive human verification process. So that is the number two. And third, I would say about bias. So data
Right.
quality and bias. You see, financial institutions, they have a vast amount of historical data, but that data often contains embedded bias. So for example, if you look at the credit decision-making systems in banks or financial institutions, every credit decision also involves subjectivity. So
Right.
whatever biases or subjectivity you had in human decision making, that is implicitly embedded in the data. And what GenAI models can do, they can actually amplify these biases exponentially. So for example, if historical lending data shows systematic bias against some particular demography or particular social group, then a Gen AI model which is trained on this data might create new lending criteria that might perpetuate or even worsen this bias. So
Right.
the issues of model hallucination, regulatory compliance, and data quality and bias, I think they are the primary ones which have to be looked into while adopting Gen AI in a financial institution.
Right. Greatly summarized. Sanjay, anything you would like to add on that?
Yeah, so on the last point, maybe I think Ritesh has very effectively covered most of the points. But on the last point, maybe Gen AI is both a boon and a bane for biasness, right? It's a maybe obviously maybe some bias would be carried forward and perpetuated or even magnified. But in some way, there's a lot of bias in how a modeler collect the data.
Right.
So what Ritesh was talking about, how the decision makers, their decisions have reflected that particular bias implicitly in the data, right? But there's another degree of or another layer of bias in how like a statistical modeler, how I collect the data, how I filter the data. That biasness could be aptly addressed because generative AI models does not assume any theoretical distribution, or maybe they don't have any thing to draw from. They learn from the data. They are data intensive methods. So that bias, the bias which I'm talking about, could be aptly addressed. However, the bias which Ritesh was talking about is the bias which could be further amplified or even made worsen in terms of some hard decision boundaries or decision rules when it comes to decision making. Yeah.
Right. Yeah, yeah. I mean, very good addition to that discussion, actually. Harshit, before we go to the next question, I mean, anything you want to add on that?
Yes, adding on to the part of the hallucinations and the biasness, right? Like what
Right.
Ritesh highlighted. So, in the recent advancement in the generative AI, there are large language models which are highly focused on the reasoning part. And whenever the model does the reasoning, all those reasonings are being displayed on the backend technologies as well and on the front end technologies as well. So we completely agree that it's a black box model, right? And we are just it's a before it was like it was out of a purview of a human to understand that how large language models were taking the decisions or how they are giving us the output. But these advancement like chain of thoughts and tree of thoughts, right? They are being better in the explainability part of the generative AI. So yeah, means whatever biasness or hallucinations we have, those can be monitored by looking at the reasoning, no, by observing the reasoning part of the language models.
Right. All right. Okay. Okay. Going to the next question that I would like to pose, and this also I'll like to start with Sanjay again. So, given the safeguards that need to be in place for GenAI adoption, can you tell us which of the biggest unsolvable financial problems can be solved using GenAI, and how to apply GenAI meaningfully to risk management, front office pricing, portfolio management, trading, etc.?
Uh, that's indeed a good question, and maybe that would determine the direction of travel for Gen AI and adoption
Right.
strategy for Gen AI in general, right? Look, the regulatory part, as Ritesh has emphasized, would still be very skeptical about adoption of the regulatory application like capital planning or maybe capital reserve planning, or some of those aspects would or provisioning under IFRS 9. Some of those aspects would still be very skeptical and they would be fence sitters for quite some time going forward.
Right.
But there are multiple different applications like pricing, like risk appetite or risk limit management, like stress testing for internal purposes, for capital future capital planning, right? Economic capital modeling, climate and sustainability risk, portfolio optimization, asset allocation. All these different areas doesn't necessarily require that much of supervisory approval and oversight, although indirectly yes, right? But doesn't the choices can be made independently of what kind of position the regulator holds. So what I see is that wherever in these many areas the data is a problem, like in stress testing, what Ritesh said, the data is scarce or it is inadequate or there's a data sparsity. We could use some synthetic scenarios, some synthetic shocks, some synthetic maybe there's an area in stress testing called reverse stress testing. Now that reverse stress testing generates a scenario automatically from the vulnerabilities of the bank's financial statements, specifically balance sheet. So the gen AI capability could be used to do more reverse stress testing in a data intensive way, right? You could give the and time series of the bank's balance sheet, right, to the gen AI, and then train the gen AI to generate some kind of vulnerability or some kind of vulnerable balance sheet, right, which basis which we could apply some shock. The model could learn shocks, what kind of shock should be applied, and what kind of prevailing a futuristic market condition, how it dent our balance sheet, right? So that is one area, right? In other way, mainly in funds, right? Many of the managed fund or hedge funds or private equity funds, right? They are theme based research, right? That research specifically in alternatives, right, like maybe green energy or those kind of things could be generated. Some of the data is generally not available for where to invest in the new opportunities or some alternative assets. Those kind of thematic research could be performed using gen AI. That's the second application. In portfolio allocation, when you try to see all possible combination which of different asset classes or different securities which could be included in a very well diversified portfolio, and how to dynamically manage the allocation, you could also generate different portfolio simulation, right? Different simulated portfolios, and then maybe use another model to see which one is the more optimized to generate the alpha or a better return for on the portfolio, for maybe, or better NAV, net asset value on the portfolio. So some of these things especially, and the other one is the climate and sustainability risk. People understand that maybe that's a new topic, and the climate data and the environmental data is generally not publicly available, right? And the data which is available also is not traceable. So there maybe you might find the regulatory acceptance as well, some degree of acceptability from regulator as well, to use the gen AI capability to generate climate scenarios or some kind of a catastrophic scenarios, which would let insurance firms, banks, to assess the risk under a climate disaster, right? So all these kind of things would require data, and maybe I suppose maybe gen AI adoption would further maybe pave the way for these kind of modeling, which are anyway very restrictive under the current regime.
Great. Wonderful. Right. So again, Ritesh, anything you would like to add to that point?
Yeah, just a couple of small points. I think Sanjay, anyways, has covered it quite comprehensively. So I think your question had two parts, Nitish, that any of the unsolvable problems which we can use GenAI to solve, and the other thing was how you can apply it into areas like risk management, front office pricing, and portfolio management. So I'll take them one at a time. See, when it comes to unsolvable problems, two things come to my mind. One is uh, the problem of predicting the market microstructure in trading. So Gen AI again can be a big boon here in the sense that it can be used to simulate the high frequency trading order book dynamics. So using these GAN or generative adversarial networks, you can simulate HFT order book dynamics. So that to me is a problem which is worth solving. And the other problem, again, from a risk management and regulatory perspective, is tail risk modeling. So right now, you use value at risk, but the biggest challenge with value at risk is that it does not tell you what happens when that particular threshold is crossed. That means what happens in the tail. And that's why in stress testing, they want you to go and get into the tail and predict something called a expected shortfall. So in that scenario, I mean, I was reading somewhere that probably Morgan Stanley or some other bank, they use GenAI to create these synthetic stress scenarios, and then they try to test how robust the bank is in each of the vulnerable scenarios. I think Sanjay also made a point around that. So around risk management and market microstructure, you can have a lot of applications of GenAI. Then, of course, if you talk about the other application areas, front office pricing or portfolio management, again, in portfolio management, GenAI can be used to create synthetic alternative data. By synthetic alternative data, I mean, say you can have satellite imagery of retail parking lots, and someone can, have a trading strategy based on that, which can be used for alpha generation. So the possibilities are immense. The idea is to someone has to really look deep into that data, figure out that scenario, then use GenAI to create that scenario and see how that can be used. Similarly, in portfolio management, I believe UBS was piloting some GenAI systems which create personalized investment narratives for high net worth individuals. So the system generates detailed explanations of portfolio construction, risk assessment, and future outlook, which is tailored to each client's sophistication level and their communication preferences. Similarly, GenAI models can process large amounts of ESG data from multiple sources, and they can, generate these sustainability assessments for potential investments, and they can create detailed reports which otherwise would take a human analyst several weeks to compile. So these are some of the things that come to my mind where GenAI can be very, very useful.
Wonderful. Okay. Again, Harshit, to you, anything you would like to add?
I will say that adding on to the Ritesh, solving the unsolvable problems, right? So sometimes when we wish to solve any certain problems, right, which are quite tough. So what is happening? Like currently we have a new means Gen AIs are very good at performing the deeper research, right? So they are so capable that at a one point of a time they can go to the 500 sources available on the internet or in the our internal databases, right? We also call it as a agentic AI. So we just engineers create a different tools for that part, and based on that, like to solve those problems, we can use the deeper research or the deeper search tools of the generative AI. And on the similar end, looking for the portfolio allocations, like there are companies like a BlackRock and everyone, they are building their own agentic AI. So when there are high net worth for certain HNIs or for their own individual investors, right? They are still it's still in the pilot mode, but they are utilizing all these agents to dynamically allocate their portfolios, or at least to provide them suggestion that where to allocate their where to do their next investment. So yeah, means slowly and gradually generative AI is being smarter in this part.
Sure. Okay. Great addition to the discussion, actually, right? The next question to
I'll
you.
give you if I can
Sorry,
intervene, I'll give
please,
you
please.
one more example. So you were talking about the pricing innovation. So especially when it comes to structured products, which have optionality embedded into them. So right now, what they would typically do is they would typically use some kind of a Monte Carlo simulation in which they would look at a historical correlation matrix, and based on that, they will generate different scenarios and then test what happens in each scenario. Now, using Gen AI, what you can do is you are not limited anymore to the historical correlation matrix. You can in fact create thousands of synthetic correlation matrices,
Right.
a traditional Monte Carlo might not be very good at doing. So again, in terms of complex products or structured products which have an embedded optionality in them, I think it could be a very powerful pricing tool.
Great. Okay. I mean, maybe let's like go to the next question actually that I would like to ask. Again, this question I would like to start with Harshit. So Harshit, since GenAI leverages the capability of LLM, that is large language models, right? Can you throw some light on building large-scale LLM capability for GenAI?
Like for building the large scale LLM capabilities, right? There are four,
Yeah,
5 points which we need to keep in mind, right? If I
sure.
talk, it's a computation, like computational power available. So to
Right.
build a large scale LLMs, we required a very high performing systems, right? We required a clusters of a GPUs and TPUs, right? And it's a massive investment. So for individual companies and means we required a very quite a lot and means quite huge investment.
Right.
But what in the current industry trends? So there are open source model or whatever private source models available. So currently, industry experts they are fine tuning the model. So there is a specific technique called the instruction fine tunings. So all the companies have their own databases, right? So instead of building the foundational model, people are focusing on instruction fine tuning or simple fine tuning of the base model,
Correct.
right? So at this point, we have a one advantage that we do not require a very high computational powers. Second point is what the orchestrations. Now it's okay, like building any language models or fine tuning the language model in the in situ system is okay. But when we want to deploy our models at the large scales, right, when thousands of users will be coming, let's take an example of the Chat GPT or the Cloud. At a single point of a time, millions of people are querying on the Chat GPT. So it
Correct.
requires a lots of scalability and a lots of GPUs and TPUs, right? That everyone will be getting the right answers, correct solutions without hallucination. Our workflow should be really good. So yeah, means we need to wonder from technical from technical aspects, right? Orchestration by the language model should be really good. Second thing, we talk about the retrieval of a data.
Correct.
Now there are features available on the means on the generative AI, right? That suppose if you have own database, a database cannot be a small, right? In the today's banking, certain banks are hundreds of years old, and they have a data means very massive data sets. So when the user queries something from the generative AI, right, from the large language model, the querying of the information by the large language model should be up to the mark. Otherwise, like the system will be completely system will not be useful. So for that part, we have to focus on the clean data sets and efficient vector deploys and creating the very good RAG pipelines. Now second thing means fourth point, if I talk about, that's the ML ops and the governance. Now when user asks the query, sometime like in our previous discussion, like Ritesh and the Sanjay have focused a lot on the hallucinations and the biases. So obviously, current language models are tends to hallucinate. So with the application of the ML ops, we can do the three things, right? We can monitor that how our language models are performing. We can also keep the security check, right? So and the third thing is the traceability. So traceability in the sense like how the people are asking the questions and how our language model is delivering the answers. So we keep the trace of the entire questions, right? What the history, what is the current output, right? And from the perspective of the data governance, it is very much important that if somebody asks, means it's possible to do the malware attacks on the generative AIs, right? So data
Right.
security is a big issues. So on that part, on the data security, we need to have a guardrails, right? So guardrails are like that it will protect our system prompts, it will protect our current data, right? And possibly it can also prevent the data leakage. So yeah,
Correct.
that is what I want to add from my end.
Okay. Sanjay, I mean, if you would like to add anything on that.
Yeah, no, very nicely covered by Harshit. Just a point that when it comes to the combination of LLM and leveraging it, further for, using the Gen AI, uh, the industry is currently in this phase where maybe many of the applications or low hanging fruits are being exploited, right? So many compliance reports, regulatory reports, model validation reports, legal documents, analysis of the legal documents, or maybe the general counsel of the bank, they have to go through multiple documents, right? So these kind of things definitely require a lot of LLM capability at its core, with generative capability in the peripheral, right, to generate new text, right? So that is where the currently the entire industry, specifically BFSI, is trying to exploit all those use cases in abundance. uh, they are not only just exploiting those particular use cases, but they are also doing a lot of what maybe Harshit has pointed out, that maybe a lot of use of baseline models and how to adapt them to those particular specific use cases, training them on specific corpus, or
Right.
specific bag of words, or specific corpus, uh, or maybe the dictum of that particular domain, to build those particular use cases. And over next 5 years, what you will see that as a result of this, many of the reporting, compliance, legal uh, legal activities of the bank, and even the financial reporting, investor reporting, investor summaries, these would be entirely be done through the combination of LLM and Gen AI capability, right?
Okay.
And obviously the parallel phase is that in we are entering into that phase, and we are very nascent stages, where we would be able to do what Ritesh and I pointed out with respect to how we could use Gen AI for financial data, like time series forecasting models, or some of the portfolio allocation and optimization, stress testing, and all that,
Yeah.
right? But Harshit is very bang on that maybe we are currently in this phase, and over next 5 years, right, there would be a lot of maybe demand and use cases to be exploited in this phase.
Wonderful. Right. Ritesh, any thoughts that you would like to share on this point?
I think both of them have spoken it quite nicely. Just one point which I may add.
Sure.
See, when we talk about building large-scale LLM capability,
Right.
probably the focus has been more on creating the infrastructure in terms of those how many NVIDIA GPUs have, how what kind of data centers you want, or what kind of
Right.
cloud computing resources you need. And that's where something like a DeepSeek had shaken up the entire system, because they showed you how to do it in a much smarter manner.
Right.
Okay, so when we talk about large scale LLM capability, and that's important for a country like India again. So infrastructure or hardware infrastructure is not the only factor. You also have to take into account data engineering, where you may be required to curate uh, domain specific data sets. And finally, some of these techniques that we are seeing, techniques like parameter efficient time fine tuning, like PEFT, where you use something called a LoRa or a low ranking adapter. What it does essentially, it reduces the number of trainable parameters. So the entire fine tuning exercise, I was reading somewhere, becomes accelerated, and the fine tuning costs can be reduced by as much as 90%. Or there are some instances where people are using something called quantization, where they make these 4-bit precision cuts, and 4-bit precision, which essentially cuts down the inference cost. So the point is, we have to build a large scale LLM capability. Probably we are entering the phase 2 post DeepSeek, where it's not only about the hardware, it's also about data engineering and fine tuning techniques. So
Absolutely. All right. Wonderful. I mean, again, very well summarized by all the panelists, right? Okay. Maybe the next question that I would like to go to Ritesh, actually, for you, this question. So is there any blueprint for integrating the LLMs and GenAI together for enterprise level capability building or built out? Enterprise level capability built out for that matter.
So in terms of blueprint, if you look at the overall framework, essentially what I have seen is companies adopting some kind of a phased architecture in which you will have a data layer where you have some kind of a unified data lake, which
Right.
consists of market data and your internal docs. Then with the data layer, you have a model layer where you will have a foundational LLM
Right.
combined with a domain adapter, something like a
Correct.
FinP, FT, or a LoRa. So you have a domain adapter, that is a model layer. Then on top of that, you do what we call orchestration, where you might have something like a LangChain for doing RAG pipelines. Then on top of that, you have security, where you do the private cloud deployment, encryption, and finally you have ML ops, machine learning ops, where you will be continuously evaluating the enterprise AI with things like weights and biases. So probably, I mean, that's how I intuitively understand it: a data layer, a model layer, an orchestration layer, a security layer, and a ML ops layer.
Understood. All right. I mean, yeah. So that's a good summary actually. Like again, thanks for that. Anything, Harshit, you would like to add on that?
So like I say that many firms just simply underestimate this orchestral layer, right? So tools like LangChain and DSP, right? So they have a capabilities to turn the static LLM outputs, right, into multi-step outputs into a good reasoning agents, right? And that is actually where the true automation happens. So that's what means. Yeah.
Sanjay, anything you would like to add on this?
Just one thing which, frankly speaking, I'm not sure that that is very prevalent, but that is also one of the what Ritesh said, that is exactly maybe how it is, right? If you journalize the architecture, but there's a uh, microservices bus layer as well somewhere in between. So many of these layers interact with the small microservices, which enhances the overall infrastructure performance, right?
Right.
They make a call to one particular foundation model or some maybe specifically adapter, domain adapter, you know so there would be microservices in between, right? Gone were the days when there would be batch processing, right? But there would be small microservices which allow these layers to interact, or what we call service oriented architecture, you know in which this particular entire infrastructure would be rolled out, right? So it is a more service oriented architecture way, the way the industry is trying to optimize that particular architecture or different layers. Yeah.
Wonderful.
In
All
fact,
right. I mean,
Nitish,
yes, please.
just to answer that same question in a different way, probably the answer that I provided was more from a technical perspective. So for those participants who may find it a bit more complex, see, you can look this entire challenge of how to integrate the LLM and GenAI into an enterprise from a very different perspective, from a more functional perspective. So that functional perspective, in my view, would be stage one. You will identify the use cases where GenAI can add value. Say you want to enhance your decision making, you want to generate customized financial reports. That is your use case stage. Then you need to have a data strategy piece where the enterprise will ensure that you have clean and relevant data for training and fine tuning the model. That's the data strategy. Then on top of that, you have the infrastructure strategy where you will invest in either cloud computing or on-premise infrastructure. That is the piece where you will handle the LLM training and inference. Once you have the infrastructure, a very important part from a functional perspective would be model governance. So where you have to implement these frameworks for model monitoring, detect any biases, and detect any non-compliance with regulatory standards. So use cases, data strategy, infrastructure, model governance, and finally a very important piece is what you call human in the loop. That means you have to incorporate human oversight to validate the Gen AI outputs, especially in financial services or BFSI or risk management kind of a domain. And finally, there has to be a continuous learning. That means you have to regularly update the model with new data to ensure that it remains relevant and accurate. So this is a different functional perspective. Use cases identified, then data strategy, then infrastructure setup, then model governance, then human oversight, and finally, continuous learning from an enterprise perspective. Yeah,
Great.
that's all.
All right. Okay, so maybe moving on to the next question that I would like to ask, and this is for Harshit to start with. Uh, can you touch upon the recent LLM advancements for GenAI and its effective integration into the financial workflows?
Today we are having no, this generative AI is getting hybrid, and for
Right.
getting it more hybrid, it's all about its reasoning mode. Now,
Okay.
if we look at the current advancement, last week we have a new release that's a very powerful language model that's in Claude 4, that is Sonnet 4 and the Opus. These two language models are very powerful, that they can generate the responses very fast with
Right.
a deep chain of thought reasoning. While at the same time, Opus 4, right? It is
Yeah.
so focused language model that if we ask to perform any deep research, right, regarding any topic, if we want to do a deep research on the certain portfolio allocations or the to see that what is the past, current, and the future of the given company, right? This language models can do an extremely deep research, right? And
Right.
second thing, like to build all this enterprise workflows, we need to have a very smart engineers and the coders, right? So these language models are so powerful and so accurate at the coding, right? So they
Yeah.
can even outperform the competition level no codes, right? When they do means competitive level coding, right? When they generate the codes. Fourth, second thing, we have a
Yeah.
more powerful model, that's the OpenAI's O3 and the GPT 4.5, right? So obviously, the latency is a very high, means it almost take a 30 minutes, 40 minutes to generate the really good quality of an output. But the output is of the standard of a PhDs, right? So certain
Right.
researchers takes around 4 years to generate certain outputs, but it will bring down the work of a certain researchers, right? Might they require a lots of time, around 3 to 4 months to do a certain literature review. Then this research model can cut down the research time by almost 30 to 40 minutes.
True.
Second thing is multimodal capacity. So these language models are not just good at the generating the text, but they are also good at vision language models. So if we talk about something if we pass certain recepts, right, or if we pass certain images, it will parse the text inside it, it will understand the image and whatever questions we are asking to it, and at the same time they are also good at generating the images from the text which we have passed, right? So yeah, at the same time synthetic data and everything are being generated, can being generated by the generative AIs. Third thing, like these language models, right, are now getting an ultra long context. So what do I mean by the context over here? That previously few months back, language models are only capable of generating text of up to certain words, right? Like 6,000 words, 7,000 words. But now this Gemini 2.5 Pro or a Flash model, they are having the ultra long context. They can read, write, and understand the context up to 1 million tokens. So that's an enormous thing. And at the same time, see, I talk about Claude 4, I talk about the OpenAI GPTs or the Geminis. These languages models are very high-end models, right? That we cannot use it in our own edge devices, right? Own system. So what people are focusing? People are focusing on having the cost-effective model. So models like DeepSeek R1 or Feed 3 or Mistral AI. So these models are so powerful that we can use this model to deploy on our own mobile or our own CPU. So yeah, for certain small financial use cases, we can utilize this small language model. You also instead of large language model, there is a terminology called a small language model for them. So yeah,
Great.
that's what I would for mine.
All right. Again, once again, wonderfully summarized. Ritesh, anything you would like to add on this?
Yeah, I think Harshit added a lot of stuff. Just a
Yeah.
couple of points I would make. Some of the key advancement, at least what I have come across. So you have, because Harshit mentioned the name of Mistral, which is a France-based company. So they came up with this concept of mixture of experts. So I think they launched the model in 2024, 8x7B. So it was a mixture of experts model which reduces inference costs. Then Harshit mentioned the issue of multimodality, where you can now process not just text but also images, audio, and video. So with me, in a practical application, the LLM can even analyze an earning call video. Instead of an earning call transcript, it can analyze an earning call video. Then I think Harshit had mentioned something called zero shot prompts or zero shot learning or few shot learning. These are the techniques where the LLM performs the task with minimal training data. Okay, and also in BFSI, people are developing new methods to make the LLM output more interpretable and more explainable. So while that might not sound very high tech, but I think it's very, very important from a regulatory perspective. So explainability related improvement, few shot and zero shot learning, multimodality, and I talked about the mixture of experts. And in terms of financial workflow integration, we are having so many examples these days, like Morgan Stanley. I believe they have a GPT-4 powered internal research chatbot, which has around 10 to 15,000 weekly users. Then there is a fintech company in Sweden called Klarna. They have an AI assistant, and I was reading somewhere that that AI chatbot handles around 7 to 800 queries, customer queries per day. The bad impact of that is they have been able to save 25 full-time employees. So good from the company perspective, bad from the workforce perspective. But this is how people are integrating Gen AI as part of their systems. So they are using them to generate code for financial modeling, for multimodal financial analysis. All these things are there. That's all.
Okay. So, Sanjay, anything you would like to add on that?
No, I think maybe most of it, but just one aspect, since maybe now the focus would be more on inferential part, how to do inference better, right?
Right.
So some of the new evolving use cases is policy compliance, regulatory compliance, audit compliance, right? So all these three form of compliance where you comply with, say, Basel norms, right, or Basel CRE paragraphs, or maybe some EBA guidelines, European Banking Authority guidelines, or some internal policy guidelines, or
Right.
maybe some auditory maybe requirements. So all these things maybe would definitely be of very prominent interest, because they require a lot of inferencing, and whatever is being said by Harshit, and maybe also reiterated by Ritesh in new form, that would be very much applicable there, right? Because we need these LLM to solve the real problems, and some of the problems processes which are very manually laden, right, and
Correct.
error prone, right? So that
Correct.
would be the way forward. Yeah.
All right. So, coming to the applications and use cases, actually, like again, that would be my next question. And again, I would like to pose this question to Sanjay to start with. So, back to the application use cases. What are the stumbling blocks in the way of leveraging such LLMs, generative AI, enterprise level capabilities for broader adoption?
One thing is obviously when it comes to GAN, generative, adversarial network, the
Right.
kind of learning they are based on is called adversarial learning, where two different networks compete against each other. They are pitted, against each other. The generator will try to generate some new data or some kind of synthetic data based on some kind of noise. So it draws something from the noise and try to make it as much make it resemble to the real data as much as possible. Discriminator try to distinguish or discriminate or classify whether it is a real data or it is a fake data or synthetic data, right? They almost compete each other in that competition or in that kind of game theoretic way, right? They try to make the discriminator try to give feedback to the generator, and over time what happens is that the generator deceive the discriminator, as if the kind of synthetic data it has created, it exactly look like, so more of resembles the real data, right? And then the discriminator fails to discriminate, and that would be the success criteria. Now, having all of this, the point is this, that the initial thing is some of the deep fake or fabricated things, or some of the things which are not reality, right, could be easily maybe projected as reality, right? So that's one of the challenge, right? How to uh, and the new research is going, maybe obviously maybe given the GAN is capable of generating content and making it look like more like real content, but how to then validate or verify that particular content. So the validation of these models, right, not only from regulatory standpoint, but even if somebody is trying to use for other use cases where regulatory intervention and oversight is not that much concerned, how to make them believable, how to validate the output of these models is the main stumbling block, right? Because obviously you could do a lot of things with these models. You could generate maybe in wealth management, you could generate recommendation, you could generate very customized personalized advice, you could generate new themes for funds, right? And based on that thematic, some money is at stake, right? If that would be completely a work of creativity, as Ritesh said, that creativity is always measured with a pinch of salt or a caution in finance. We do not like people or even our models to be too creative, right? We wanted them to be too realistic, right? So
Yes.
that's the challenge. Realism versus something maybe which is purely of art of work of fiction, right? How to separate fact from fiction, so that would be the challenge going forward. Yeah.
Wonderful. Harshit, anything you would like to add to what Sanjay has already mentioned on that point?
Like, I would like to say that we need to have a very good cultural shift, right? So finance people are very good at the spreadsheet and applying the formulas on the spreadsheet. So we just have to make them a habitual, right? We have to create a habit for them that how to use this chat GPT models. So for that, we need to educate them. We have to uh, build that trust on the generative AI models, right? And also at the same time, we also have to bring the transparency that how the models are reasoning. So that is where it is much needed.
Absolutely. Ritesh, your 2 cents on that. Anything you would like to add?
Just a couple of points. I mean, one big stumbling block is scarcity of hardware.
Right.
So if you look at the availability of some of these NVIDIA Tensor Core GPUs, that availability, that lead time might be like 7 to 8 months today. Then again, a huge talent gap in terms of the number of LLM engineers which are required globally, plus what you have available in the market today. And then a big issue is how to integrate these systems with the legacy systems, because sometimes in the hustle and bustle of these latest technologies, we tend to forget that uh, around 40% of the global banking system, and I'm talking about the core banking system,
Right.
still runs on COBOL.
Yeah.
I mean, a lot of people amongst our participants who are young people, they might not even have heard about this language. COBOL
Yes.
is like a 60, 70-year-old programming language, which still runs the core banking infrastructure for many of the large global banks. That language was designed for batch processing, like end of day transactions, payroll processing, and around 40-45% of banking systems globally, even today, runs on COBOL, where the key components are there would be an IBM series mainframe or some of the older database architectures. Now, the problem with COBOL is that it's very, very difficult to integrate with GenAI. First of all, because COBOL stores data in proprietary format, something called an EBCDIC, which is incompatible
Right.
with the cloud and AI APIs. The second big problem is COBOL is batch oriented. The processes are generally run at certain frequencies, whereas GenAI requires real time streaming. Okay, so I was reading about some US bank. So they uh, created a GenAI system or an AI
Right.
system for fraud detection. And when they were there at the proof of concept stage, at the POC stage, the accuracy of the model was 98%. But what this GenAI system was doing, it was analyzing the payments for anomaly and highlighting any
Oh,
concerns or frauds. When they put it
right.
in the production system, they realized that their COBOL core that could only export data on an hourly basis, not more frequent than that. So AI was
Right.
receiving some kind of a stale data. So 98% accuracy at the POC stage, and then in the production stage, the accuracy went down to 70%, which was a huge degradation. So that is again a big
Correct.
challenge. Plus, yeah, I mean, when it comes to COBOL skills, because people don't learn COBOL anymore, I think the total
Anymore.
number
Yeah.
of COBOL developers across the world today is not even 100,000. So there was a case when Commonwealth Bank in Australia, they were trying to replace their COBOL core. It took them 5 years to do that because they did not have enough trained COBOL developers. Because and a lot of these COBOL business logic in that time, the modern practice of documentation and creating extensive documentation was not so much. So a lot of business logic is buried in these millions of lines of code base in COBOL, which does not have very explicit documentation. So practical challenges.
Wow. This is very interesting. All right. So maybe like again, the concluding question that actually I would like to ask again, that I would like to start with Ritesh you only. So can you share some insights on the pace of how GenAI adoption in BFSI and what is the future outlook?
Sorry, can you repeat that?
No, so I'm saying the question is like if you can share some insights on the pace of GenAI adoption in the BFSI and what how the future outlook look like.
Yeah, so I'll just want to give some high level
Right,
view. So there, I think
right,
last year there was a report by McKinsey and Company on GenAI adoption, and they said that around 35 to 40% of the banks, they are doing some kind of a pilot around GenAI. And
right.
as per that McKinsey report, the top use cases of GenAI adoption in BFSI, first of all, was customer service. That was the most prominent use case. Then compliance, and then risk management.
Okay,
And again, some of the reports cite that the biggest barrier to adoption of Gen AI in BFSI is regulatory uncertainty and compliance. Okay, and when it comes to outlook, in terms of outlook, I think this EU, the European Union AI Act, compliance with that is a good thing because that will drive standardization in the market. So that's a good part. And I think Harshit was mentioning about some of these SLMs or small language models like Microsoft V2. So
yeah,
I was reading somewhere that that's going to cut the cost, that could cut the cost by about 8x to 10x. Okay, which is a huge cost saving. So on economics front, I think people might be looking at some of these small language models much more favorably. And then again, in terms of revenue impact, that McKinsey report says that GenAI will add some $200 billion to $400 billion annually to banking. But then again, these are forecasts. But from a high level view, I think adoption rate is there. It's something which every bank in the town is doing something or the other around it.
Yes,
Customer service, compliance, and risk being the core focus areas. But
correct.
yes, explainability, interpretability of the model, and regulatory uncertainty and compliance, they are the high level big issues. Future may, with standardization, especially under the EU AI Act and adoption of these SLMs, so the small language models, I think cost will become more reasonable. So these are some of the high level points I would want to share.
Absolutely. And of course, we would like to hear on this point from Sanjay as well. I mean, he has been working in this part of the industry for quite some time. So Sanjay, again, your thoughts on this as well.
On a lighter note, I would first of all say one joke, that not joke but a real thing, right? You could treat it as a discriminatory, whether I'm saying a joke or is it a real thing or a fake thing. For on this panel, Ritesh is our generative AI, right? He has this generative ability of creating ideas, creating content which I could not at least level up, right? So all kudos to him, right? But yeah, on this note, maybe I just I haven't read anything recently, but from my experience observation, many of the asset managers, fund managers, wealth managers, portfolio PMS firms, portfolio management services. So the main dependency on somebody who is somebody taking the investment decisions, or identifying maybe the theme to be invested in, or the asset classes to be invested in, or maybe the broader how to diversify the portfolio. You would notice that recently there the kind of fee they would used to charge, management fee, right, investment management fee they used to charge, has been drastically reduced. So
Yeah,
it talks a lot that some part of that particular activity which they were doing as asset manager, wealth managers, portfolio managers in PMS services has been replaced by Gen AI, right? And the new themes are getting generated, and they are as good as many of these portfolio managers used to generate themselves or curate themselves. So
correct.
I hope that that is one area. The other part is that the embedment of sentiment indicators into many of our models. Now sentiment is one thing which is very biased, right, which is very biased.
True.
uh, you could learn from the data using NLP. You could learn from tweets, you could learn from analyst reports, you could learn from forward guidance, or you would learn from earning calls, all of that. But how to maybe for a future scenario, how to predict, how to generate such sentiment driven scenarios which could be embedded into the model as a sentiment index or as a sentiment indicator. So that is another maybe application which is worth looking into, and people are looking into it, because now the idea of using the NLP to process the sentiment data, or to at least classify, build a classifier on identifying whether it is a bullish sentiment, bearish sentiment, or a neutral sentiment, that is done. That is a done and dusted problem. Now the idea is how to generate sentiment driven scenarios, like maybe Trump getting elected to power, what would happen to the world, right? If
Yes,
Iran versus Israel war broke up, which is real now, right, how the supply chains will be disrupted. If Russia versus Ukraine will prolong, right, what kind of downside effect it would have on Europe, whether it would be pushed into dark ages or some kind of thing. So those kind of things may be purely sentiment and perception driven things, where uh, there are scenarios like emerging market hard lending, right? What is happening in the developed world, right? How maybe investor would react to emerging markets, whether they move back money, pull out money from the emerging market all of a sudden, without looking at fundamentals, without looking at technical charts. So all these kind of sentiment driven thing are more maybe maybe capturing the whims and fancies of the markets and modelers, because we are living in the world of exuberance, right? Irrational exuberance, and I don't know to what an extent these fundamental analysis and technical analysis make any sense at all, right? So that's what my feel is. But over to maybe Ritesh, maybe his
Maybe
generative capability.
the only point I would want to add, Sanjay, to what you said is that compared to rich bankers and data scientists, the poor teacher and trainers have to read up a lot. So I think that's
No,
the irony. We have a lot
we
of free time hours to read.
no, we are large language models, but if you apply us to real life problem, you stuck with the architectural thing, bottlenecks. You are a small language model, and you are very much usable in every context.
Thank you.
Okay.
All right. So, parting thoughts from Harshit on this. Anything you would like to add?
So like I would like to just add on one thing. Like this language models are very probabilistic model, right? So like we just need a certain regulatory framework, so we can just experiment with the language model in that particular regulatory sandbox. So before going at the production grade level, right? Because in the finance, like the regulations plays a very crucial role. So that's what I want to add on this part.
Wonderful. All right. So that was like a very
I would just
intense.
want to add
Sorry. Yes,
one
please,
statement, Nitish, as a closing
please.
statement, which probably can summarize this entire discussion. See, when it comes to BFSI and finance, Gen AI is transitioning from being a hype to something which has to be focused on ROI. So today, when you talk
Correct.
to people, the priority is security, the priority is accuracy, the priority is regulatory compliance, and the priority is whether they are getting a bang for the buck or not. So I mean, it's no longer about technological hype; it's about what you can actually deliver. And I'm sure Sanjay can probably validate that as to how companies are thinking now.
No, definitely. That's the point. Maybe it has clear the air, right? Because there were many POCs experiments which landed nowhere, right? And the return on investment and what the point Ritesh said about COBOL and legacy infrastructure and the challenges in front to back integration, that is holding the key. That is holding banks, but obviously maybe with fintech being the challenger, and maybe these champions are no more champions, at least, right? They would have to do something in the coming years, right, to radically transform themselves. But definitely, yeah, that's the case. The buck for the real buck for the money is where the everything maybe starts or stops. Yeah.
Oh, wonderful. So I think that has been a very intense and very, very informative session. So from all the panelists, I mean, a lot of the insights and a lot of thoughts. I mean, we got to know a lot of things. So even the participants, I would think they would appreciate actually, like again, we got to know a lot of things. Okay. So, I mean, now, like, of course, we would be having the Q&A, but before that, as I promised, we would have the quiz as well, right? All right, so now to the exciting part of the session, we would be going into the Q&A part, right? Okay, the questions actually, like again, how we would go about is like there are 5 questions. We will be posing the questions, and all the participants would get like uh, 10 seconds to answer the questions, and after that we would stop accepting answers. So for each question you would have 10 seconds to answer, right? Okay, so let's start with the quiz. And I mean, the winners actually, like again, I mean, top 5 people would be selected as winners. If there is a tie, then the fastest people to answer the questions will be getting like the, I mean, you would be having like you would be declared as winners, right? So okay. So with that, let's go to the quiz. So now, like again, question 1 of the quiz coming up. All be ready with your to answer the questions, right? Okay, so here we go. The question is, what is the primary purpose of just a minute, it's like a little disturbance, sorry for that. What is the primary purpose of auto encoders in generative AI? A, to encrypt data. B, to automatically encode text. For dimensionality reduction and feature learning, that is C, and D is for accelerating network performance. 10 minutes, everyone. Oh, apologies, 10 seconds, everyone. All right, quick. Answers. All right, let's stop answering 1, 2, 3. Okay, so let's stop answering question 1. Question 2 coming up for all. All right, so the second question is, what is image segmentation in generative AI? A, reducing the size of an image, dividing an image into parts for individual analysis, converting an image into text, enhancing the resolution of an image. 10 seconds, everyone. All right. We'll stop answering the question now. 1, 2, 3. Okay, stop answering. Okay, going to the next question, which is, which of the below is false about generative adversarial networks? So in this question, please note there can be 2 or more points that can be false as well. So you have to mark as, I mean, your answer as A, B, C, D, or you can mark as A and B, A and C, B and D, so on and so forth. Okay. The generative network is used. Generative network G uses feedback from the discriminator D to learn to generate synthetic data that ideally resembles the original data in key aspects. Generator loss penalizes the generator for deceiving the discriminator. Discriminator is a classifier that receives real and synthetic from G data and attempts to distinguish and classify them. Discriminator loss penalizes the generator for miscalculations. You can start answering now. 10 seconds. Okay. Stop answering in 3, 2, 1, 0. Please stop answering this question now. Okay. Going to the next question, the fourth question coming up. Global banking implementation LLMs across US, GLBA, U, GDPR, Singapore MAS, best security framework. A, centralized processing with global encryption. Federated learning plus zero trust plus region-specific data residency, public cloud with standard encryption, and open source with manual governance. Start answering now. 10 seconds. All right. We'll stop answering in 3, 2, 1, 0. Stop answering this question now. All right, going to the final question. Which loss function is commonly used in GANs? A, cross entropy loss, mean squared error loss, binary logistic loss, Kullback Lever divergence. So start answering the questions now, 10 seconds. All right, so stop answering the question now in 3, 2, 1, 0. Thanks everyone for participating in this quiz contest. So we'll be declaring the winners after tabulating the results. But before, now let's go to the Q&A. There are a lot of questions actually that people have sent, and we will be taking up those questions. In the meantime, anybody wants to discuss anything regarding this field, any guidance that you need, any course you get interested that we conduct, this is our contact details. Please feel free to connect with us. All right. So with that, let's go to the questions. Okay. So the first question is from Arvind, and he has asked, can we create strategies using indicators if we have the historical data of equity and FNO? If yes, where can I get the complete data for backtesting? And how do we use generative AI to integrate the historical data and idea to formulate the strategy? Anybody would like to answer that question?
So let me give it a go. Is
Sure.
this Arvind? Hi Arvind. Thanks for asking question. I think your question is more about how we could use equity and FNO data to backtest the model, to backtest the trading strategy. Is that the case? And
Yeah,
then
so basically he has mentioned that basically the intention is to create uh, certain we have mentioned tuned. Oh, okay, it's fine-tuned rules to automate the trading activity. So he has misspelled actually.
okay. Let me maybe start with the answer. So ideally, maybe equity data, especially maybe and equity index data like S&P 500 is generally available. Maybe the most easily access would be Yahoo Finance, or maybe there are multiple other ways, even through directly from S&P API, without having to do anything. You could you maybe simply import the data, and you could do it in Python by doing some kind of a web scraping or direct import from using the API keys from many of the data providers. So that's the data is available. Specifically equity data and FNO data is one part of the whole financial data which is very readily available and with very long time series. So data is not the problem in that case. You could obviously use that particular data to do some kind of a deep neural network, specifically recurrent neural network, which, or maybe the LSTM, long short term memory, or gated recurrent unit, or a hybrid, to do a prediction task, right? Maybe whatever you want to do, right? You like, what would be the forecast for the next period, or the forward looking forecast on your problem. You could also maybe calibrate your strategy, right, based on that particular data. So you can do your strategy back testing, as calibration as well as back testing, using some of the historical data. You can do PNL attribution as well using that particular data. Now the second aspect which you pointed out is how to use GenAI. Right now, GenAI, sometimes there are many stylized facts about financial data, right, which maybe enforces a theory and some assumptions about the modeling, like maybe about volatility, that volatility clusters, right? About maybe autocorrelation, serial autocorrelation, that beyond a very short term time frame, the serial autocorrelation are absent, right? About maybe the homoscedasticity, that the distribution is always same across different time stamps. That's not the case. The data looks very heteroscedastic. So there's volatility clustering, there's a lack of serial autocorrelation in the time series. There's a maybe a heteroscedasticity where the distribution would change. There would be fat tails or heavy tails as well. There would be asymmetry between loss and gains. All these stylus effects make us do the modeling using some of the theory and making some assumption. Now the generative AI is a data driven way, where rather than building making some theory about that, okay, this will hold across markets, across different time, across different instruments, we would let the model be trained through data, and we would be sampling the data from various indices, not just one indice or one market, from globally many indices, CAC, DAX, S&P, and then using the generative ability of the GAN network to generate a synthetic data which is more like you know a broader pattern on that particular equity asset class, right? So with this new data, fresh data, or some synthetic data which would be representative of the entire global uh, you know uh, returns on equity, right, we could then maybe further maybe use that particular new data to build a new model, rather than building the model purely on theory or purely on some kind of assumption which we hold, which generally doesn't hold across markets, across time frames, across different instruments, across different micro markets or indices. So that's where maybe I could think that Gen AI could be leveraged, right, to build a better strategy, right, in order to just free up maybe the modeling from any assumptions or theories or stylized facts which are generally observed in one market but not necessarily observed in every market. Yeah.
Right. Okay. Anyone wants to add anything, Ritesh or Harshit?
No, I think Sanjay made a very comprehensive answer to that. So that's good.
So maybe going to the next question, which is from Ahana, and she has asked, how are we predicting the next token in Gen AI? Maybe like I'll like Harshit to start answering this.
See, there is a function called the, I'm just, it's being very mathematical right now, right? But let's say, like, I will say the cat sat on the, right? So after on the, there is a, let's say, means we have to fill it, right? It's a, like, we have to fill in the blanks.
Right.
Now on this part, there can be a many multiple things, right? The cat sat on the mat, the cat sat on the table, the cat sat on the door, the cat sat on the bed, right? There are multiple probabilities that are where cat has sat. But when we talk about this, GenAI works on the core architecture of the transformers, right? So what does this transformers do? They try to build the context, right? Reading on the left side of the sentence and reading on the right side of the sentence, right? And based on that thing, GenAI build the context and it will predict the next token, right? That the cat sat on the mat. So this is how it happens, but there are many things called as the softmax probabilities, transformer architecture. On top of it, they have something called a language model head, right? So all these linear projection and the softmax probabilities are being projected on the LM head, and LM head is a no, LM head is a giving us the temperature, giving us the frequency that this should be the next word, right? So it's a quite a technical answer. I have to take it at the depth in this part. But
I
based
mean,
on the context, it answers it.
no, that's like well summarized, of course. Sanjay, anything to add on that?
No, I think it's well summarized. The only thing, yeah, very simple mathematical explanation is in a multi dependent, multiple dependent things, right? Where the previous sentence or previous word and maybe previous to previous, that paragraph or context itself is important. Sometimes you do train the model using a joint distribution, right? Like all these things, given this context, this previous word, this verb, this noun, this adjective, this previous sentence, now let me know what is the probability or likelihood of getting the next token, which one, which particular word will appear the next, or which token will appear the next with the highest probability. So that's maybe the very simple, very basic, right? And maybe Harshit has quite added colors to that. Yeah.
Wonderful. All right. So I think there is a lot of questions still remaining, and again, we are already 20, 25 minutes past time, right? So maybe like again, we'll quickly go to the next question. Next question is from Rakesh, and he has asked, can you talk about how we can leverage GenAI in financial research on the fundamental side, equities and fixed income, and what oversight measures could be set up to avoid hallucinations, biases in input? Anybody would like to answer that?
I would like to answer on that. See, when we talk about the very fundamental research, right? So today's generative AIs have a capability to go to the internet and perform the deep research on the particular equity or a particular stocks. So the main context comes out to be the writing the very in-depth prompt. So in this part, we require the skills of a prompt engineering. So whatever, I'm just not able to recollect everything, but suppose if we wish to see that how the current stock is going to perform, right? So if we wish to do means in that particular prompt, we should acquire everything, that what is the current asset of the company, what is the loss of the company, how much profit it is making, where the following company is going to do the next investment, in what verticals it is trying to expand. So things comes out to be that our prompt should be very should be in the very deep, right? That see, generative AI do not understand, right? Like what we want as an answer. It's on us that how we should ask them the question, right? And regarding the part of the hallucination, to control the hallucination, there is a something called the system prompts, right? So generally, engineers have the duty to control the hallucination of the language model. But now this all these language models are also giving us the power, right? That by passing the system prompt inside of a language model, we can control the hallucination of the language model up to certain extent. But currently, the language models are so powerful that they tends to hallucinate a very less.
Correct. Yes. Anyone would like to add anything, Ritesh or Sanjay?
Yes, I can add something to it. See, I
Please.
think Harshit spoke about it pretty comprehensively, but just from a different perspective. So Rakesh was asking that how can you use it for fundamental financial research? I would rather break it down into multiple steps. So the first step, Rakesh, would be that you gather data for analysis. So where the LLM will help you there using a tool like say OpenAI's GPT-4V. So any LLM which has OCR, optical character recognition, and using say some kind of a PDF extract tool, you can do an automatic data extraction these days, where you can extract data from the SEC filings, the earning call transcripts, industry reports. Once you have done that data extraction, next step is sentiment and qualitative analysis. Again, you can use LLMs like say BERT, or you can do a competitive benchmarking using one of these tools. Then you can do financial modeling. So because you're talking about fundamental analysis, I'm assuming that you will be doing a DCF modeling. Okay, so using something like a Python and LangChain, you can do an automated DCF setup where you can say something like generate 3 plausible revenue growth scenarios for NVIDIA based on say the current AI chip market share plus the Taiwan semiconductor manufacturing company's capacity constraints, and you output as a CAGR range. So it will tell you the output of a bull case, a base case, a bear case. You can also use LLM for doing thematic research. So you can identify the emerging investment themes, and then you can use a technique like BERT topic on all the risk factors which they put up in their 10K statements. And finally, you can automate institutional grade research reports. So I would break that problem into 5 parts: data acquisition, doing a qualitative analysis, then doing a financial modeling, then doing a thematic research, and finally doing a report generation. So that would be my take. And also you mentioned about how we can use, how we can mitigate the problem of hallucination. So one very simple approach is, which a lot of people use these days, is something called a retrieval augmented generation, or RAG. So for example, if LLM says a fact which looks reasonable but false, say the LLM says that Apple issued a 10% dividend, the solution is you will force the model to cite the source from where they got this data. So that will be a RAG correction. Or these days you have something called schema enforcement, using which you can constrain the output. So for example, say the LLM invented a matrix. The LLM tells you that the P ratio is 150x for a bank, which is absurd. So you can force a structured output within valid ranges. So I was reading somewhere that Morgan Stanley actually uses this schema enforcement to block absurd EPS estimates, which the LLMs tend to throw. And third step would be human in the loop validation. So, critical errors, they sometimes slip through. So you can have these predefined validation checkpoints. So for example, if AI has drafted a research note on any topic, then system will flag all numbers beyond a certain threshold for human review, and the analyst will confirm or reject before the report is published. So some of the points which you can use.
Very, very, very well summarized, actually. I mean, maybe going to the next question from Anay. Anay has mentioned we have seen open source breakthroughs in LLMs like Mistral. Do you see similar possibilities emerging for open source GenAI models specifically tailored for financial applications, and what challenges might slow that adoption?
Sorry, I did not understand the question. Can you repeat that?
Yeah, sure. I'll repeat the question. So it's from Anay, and he has said that we have seen open source breakthroughs in LLMs like Mistral. Do you see similar possibilities emerging for open source GenAI models specifically tailored for financial applications, and what challenges might slow that adoption? Maybe again we can start with Sanjay on this answer. Sanjay, would you like to answer this question?
Yeah, I would be very quick on this one. So look, Gen AI need to be, it cannot be domain agnostic, right? It need to be very domain specialized and domain trained on specific things. And there comes the challenge of data privacy, data confidentiality, GDPR, all these kind of things. So uh, a one size fit kind of a standardized solution would do as good as being trained on something which is very generic, right? You need to maybe still have adaptation of that to your particular use case. So that's why in the Gen AI space, generally, unlike maybe the LLMs, you don't have a lot of those kind of standard pre-trained kind of models, baseline models, right? But I'm not very closer, but maybe I'll like Harshit and Ritesh to share more if they see that over next few years it is good that such solutions are going to be readily available for people to leverage. Yeah.
I mean,
Um,
my take on this would be that we anyways have these open source tools in most of the areas. So if I take up foundational models, for example, then something like a Llama 2 or a Llama 3, that is some kind of an open source model. And in fact, Bloomberg GPT uses a very similar architecture. Or if you talked about Mistral AI, that is an open source model. Or Google, the Hugging Face BERT, FinBERT, these are actually open source models. And I would want to go a step beyond that. So it's not only enough to have an open source LLM, you also need to have open source tools for data processing where you can curate domain specific data, because Sanjay mentioned that point that it cannot be domain agnostic. So you have these a plethora of tools these days. You have Scrappy, you have Beautiful Soap, where you can scrape through the Edgar filings in US for 10K filings. You have something like Apache Spark, where you can scale the market data. For fine tuning, you have things like LoRa, which is the low rank adaptation. Then you have to reduce hallucinations, you have RAG, which is again a open source stack. Uh, so I find that at every stage of the uh, Gen AI value chain, you have some or the other open source tools. At least that's my understanding based on whatever limited understanding I have.
Um, Ritesh,
Yeah.
Yeah.
yeah,
So
well
maybe
said.
like again, thanks. Again, that's a good answer. Like again, I hope you got that answer. Maybe again, it would be the last question for the day because again, most of the questions we have answered directly, indirectly. Maybe a very general question which we would answer and then we'll stop because other questions we answered and I mean it's already past time. I mean, one question from Aditya is that what is the current situation for quant finance in terms of opportunity in India? Very quickly, Sanjay and Ritesh.
Ritesh, if you go first, then maybe I'll add.
Yeah, I think, see, when it comes to quant finance in India, uh, whatever reports I read, especially some NASCOM produces some of these reports, and they say that it's growing at a fairly decent place. What I've seen in some of the industry reports, three key areas where they find application of quant finance. One is algo trading, in risk management, and then you have robo advisory. And if you are asking about some of the companies which are acting in this space, of course you have. So if you talk about domestic quant firms, you have Quant Insti, you have Algo Trader, then a lot of global banks. So JP Morgan in Mumbai, they have an AI ML hub. Goldman Sachs has a Bangalore-based quant team where they do a lot of work in terms of derivative pricing and risk. The first ones I talked about, Quant Insti and Algo Traders, they are effectively into HFT, and they are also doing a lot of retail algos. Then you have some of these fintech startups like Small Case, which does a lot of strategy kind of a thing. Some of the asset managers, ICICI Prudential, Quant Mutual Fund, they are trying to do smart beta and factor investing. So, I mean, uh, if I can summarize this in, say, a line, I have seen a wider recognition even amongst the retail players that the future ultimately lies in data-based quantitative trading. I'm only talking about the trading aspect. Similarly, amongst banks and asset management companies, when they are doing risk modeling, when they are doing risk management, they are trying to figure out portfolio related strategies. It has become a given thing that quant finance is a skill which is valued a lot. So to ask me, I think it has a good future in India. Some of the, even institutes like, if you look at the Indian Statistical Institute in Kolkata, they have a financial engineering program. IIT Bombay does a quantitative investment course. And again, the when it comes to the regulator also, SEBI has already said that algo strategies are all fine. It's just that they have to be subjected to SEBI back testing. Okay. In fact, I think in 2023 itself, SEBI allowed AIML in mutual fund risk modeling, as long as it is explainable. So my personal take would be that quant finance has a bright future in this country, given that everything is becoming data driven, given that speed of execution and how fast you are able to execute these things matter a lot. uh, I think it has a good future. Yeah, that's all from my side.
Yeah.
If you can add something to it just quickly, we'll wrap up the session.
Yeah. So exactly. So quant finance or quantitative capabilities in financial engineering are not only now confined to big Wall Street banks, right? There's a wider maybe recognition as well as adoption of quant finance in every area, even in retail banking, microfinance, peer-to-peer lending, right? Those some of the very low, some of the bread and butter kind of businesses of banking. But in general, what I have seen is over last specifically 7 years, right, the quant finance roles, specifically the model validation role, model development role, model governance role, the pricing roles, many of the product companies in India, right, which are global product companies like Numerics, Murex, Quantify, right? They provide very strong foundation, and they have a good base headcount in India, and which is ever expanding into maybe hiring more into from the quantitative discipline, people who are generally aware about the financial engineering and quantitative finance, specifically for valuation and pricing kind of roles. And I see a lot of upside going forward, that the valuation and pricing will kind of roles will grow even further. Risk management, it's already that India is a big uh, part of the value chain, overall global value chain. In risk management, we have many firms like JPMC, Morgan Stanley, Goldman Sachs, UBS, RBS, right, Barclays, right, HSBC, all of them have big big presence. They have dedicated functions or departments which are model validation, model development, model governance, model audit, right? But yes, obviously, the pricing and valuation is something like which I see as a very cheese thing, right? But that is also growing up. The share of India's participation in the overall global workforce is growing up, as well as in some of the retail or consumer banking or peer-to-peer lending, those kind of areas. So definitely, it's a very very bright future, and somebody who wants to learn it should not be fence sitters. They should be rather getting onto the train. Otherwise you will have the effect of feeling like you missed the train. So
Yeah, wonderful. Right. So, I mean, with that, we have come to the conclusion of the session today, right? So, first of all, thanks to all the panelists for joining in. Sanjay, Harshit, Ritesh, it was really great. I mean, with the knowledge that you have shared, I'm sure all the participants would have had a lot of insights that they will take from here. And thanks for answering all the questions patiently. We do have few more questions, but again, those are generally with what we have already answered. I mean, most of the so, and anyway, we have overstood time today. It was so engrossing. So thanks everyone for joining in, and see you again in the next webinar. For all of you, again, you all know, I mean, we regularly conduct this our IQF deep dives with expert series. So we'll keep conducting these webinars every month, once or twice. So keep following us in our different social media pages, websites, and everywhere. So we'll and keep track of the next sessions. Thank you. See you again in the next session. Thank you all. Thank you.
Thank you, everyone. Thank you.
thanks.
Have a nice day.